Hello, everyone. So, quick introduction about me. So, my name is Jeroen Pinoy. I've been working with MISP for quite some time, and now, recently I started doing some security research and also code review of MISP. So here you see my details. Maybe something funny about me. So some of the things I found in this research, I actually found while taking a bath. So some people also call me the Batman. Very short introduction to MISP. So for most of you, probably MISP is quite, you already know it, but I just wanted to show as well how I typically introduce the tool to other people. So imagine that you have an adversary that's after something that you want to defend. To be able to protect it properly, you need to have certain information like the intent of the attacker and so on. If you do not properly defend yourself, then what can happen is this. The attacker actually manages to get to the target. There was supposed to be some sound as well, but okay. Anyway, you get the point. So imagine we want to, as a next step, we want to actually take action on this. Some important things to know here is that the attacker is only interested in Häagen-Dazs. So if you have Magnum ice cream, it's not a big deal. You can just leave it on the table and nothing will happen. Cat can jump 2 meters high. So a potential defense strategy here is just keep Häagen-Dazs ice cream on shelves higher than 2 meters. And fine. We share this with the community. That's all fine. Except after doing that, somebody came back to us and told us, oh no, I actually put my pizza higher than 2 meters, but Cat was also interested in that and managed to steal some pizza toppings. So the fact that we didn't share the correct details actually led to somehow the attacker still getting what they want, but the fact that they got back to us, we can now take extra mitigating action in the future. The reason why I start with that is because it's a much more practical example. So even for technical people, it might be easier to understand. And then we can abstract to something in the cyber industry. So imagine you have a targeted phishing campaign with somebody going to LinkedIn to get details about you, then crafting a phishing email and so on. Your SOC detects it. You can now share the same kind of details about the campaign and the IOCs with others. Now, how did this research get started? I've been involved with MISP for more than 5 years, and as part of my job, I had a look at the Cerebate project because, I had 2 goals here. I wanted to check, can it help us, and how it is built. So it looks like it can help us. I'm very excited about the future of the project, but maybe to explain a bit of how it works. It's built in Cake PHP. It's a MVC PHP model. So if you know MVC, if you know some PHP, it's quite easy for you to also go through the code and to figure out what it's doing because it's an imperative programming languages. So I went through the code and I found some security vulnerabilities. The main one here being if you were an org group admin, so that's, for example, a national representative, you can take ownership of any organization that's on the platform, and by doing that, you now become the admin of all the users on the platform. After I did this, I got a taste of some security research, let's say, and I had also been involved in the MISP project for a long time, so I thought what I would really like is get to the point that I deserve to wear a MISP hoodie or a MISP project hoodie, and I also thought that would be cool in the future if I do the same for other projects. Again, it's more a personal thing. I just want to have the feeling that I contributed to something, and then later on I can look back at it by either wearing the hoodie or by just looking at it, let's say. So how did or which approach did I use here? I used my beautiful eyes because there's a lot of pen testing happening already of MISP, and these people have usually use more technical measures like fuzzing and so on. So it didn't really make a lot of sense for me to use the same approach. I thought, I have knowledge of MISP itself, so maybe I can use a different approach. I did mostly code reviewing and exploratory testing. If you're not aware of what exploratory testing is, it's basically a very fancy name for just clicking around everywhere and filling some stuff in. And then I also thought, well, let's use some LLM, because why not? So these are the tools I use, JetBrains. Apparently this is actually revolutionary to some people. I also use the step debugger. So in PHP Storm, that would be Xdebug. For LLM, I used Kagi Search and Assistant. And then a lot of the reviewing I do is actually on GitHub. So I'm just using GitHub, scrolling through code, scrolling through commits, or using the search. And if I ever need to change payloads and stuff like that, I use Burp Suite Community Edition. As a strategy, I decided to focus on some specific areas first. So the first thing was I prioritized critical components, let's say. Then I looked for specific vulnerability types. I pivoted on recently disclosed vulnerabilities, and then I looked at configuration options inside MISP to get some inspiration. So looking at critical components, the first one I had a look at was the user management and the outkey management. Outkey in MISP is the name for API keys. To understand a bit what can be found here, you need to understand the MISP roles. So you have at the top site admins. They are basically the king of the kingdom. That's the root equivalent on a Linux machine. Just below that, you have sync users. Sync users are quite interesting because normal users inside MISP, they are divided per organization. And if you're part of an organization, with a normal user, you can only create data for your own organization. But with a sync user, which is intended to be used for syncing between MISP instances, you can actually create data in name of another organization. Below sync users, you have organization admins. They can manage users within their organization. What's a bit special here is that an organization admin can also manage a sync user, even though often they don't have a sync permission themselves. So if you have inside an organization a sync user, you can in a way, escalate your privileges to a sync user. And then below that, you have the plebs. That's the normal users who nobody really cares about, let's say. And what you want as an attacker is to get the site admin account to become the king. As I mentioned, MISP is designed to interconnect separate systems to share information. So as an example, you can have here a MISP community, which is targeted more to the private sector. For example, banks. You have national certs like Circle, who is doing governmental stuff, and also commercial things. And then you might have a more military-oriented organization having their own community as well. And these could all be interconnected through MISP communities. What did I find here? So this is probably the biggest vulnerability I found, let's say. So if you had an organization admin, you could create an authentication key for a non-admin user which belongs to a different organization. So while through the graphical user interface, you would never manage to get that option yourself. If you used the URL and you just went to Outkeys add and a specific ID, it allowed you to actually add a key for such a user. So you could either iterate over that, or there was another spot which leaked information about IDs and roles which would allow you to know who you can target. What can this do? Maybe first to look at the code. So I was reviewing this and I realized there was a check missing. There is no check for the organization ID. Impact here, you can see data of other organizations. So once you're part or you get access to another user belonging to another organization, that means that you have visibility on all the data that's visible to that organization. So if you didn't have visibility on that data before, now you can have. On top of that, imagine that your organization didn't have a sync user. You could also create an authentication key for that organization's sync user, so you have some privilege escalation. And another interesting thing to note is that some organization, the host organization, that's the organization of whoever is maintaining the MISP, they also have some special permissions. So if you manage to get a user from that organization, it's again privilege escalation. Second thing I had a look at was the logs. There were several vulnerabilities here as well. The main thing, or the two main ones I will mention is if you were using the log search through the graphical user interface, you could get all the logs instead of just the logs that were supposed to be accessible to you. or all the logs of your organization. And then the second one was that there's a lot of API keys and so on that you can configure in MISP to access external systems. And a lot of these were logged in clear text in the logs when you changed them, which means that if somebody somehow manages to get access to the logs, which I could with this other vulnerability that I just mentioned, you can potentially get a list of API keys for external systems and then have lateral movement. So the impact here is potential lateral movement, potential privilege escalation, and it's an extra powerful attack chain if you combine it with the previous vulnerability. The second strategy I had was to look for specific vulnerability types. So I had a look at the OWASP top 10. I was a bit surprised to see some of the things that were mentioned here, but okay, so these are the ones that I specifically wanted to focus on. And then I asked, I both looked myself and I asked LLM in this case, I'm looking for these types of vulnerabilities. What could I look at in the code that might lead to these vulnerabilities? And it managed to give me a pretty good guide of functions and patterns that I could look for. So what does that look like? For example, for cross-site scripting in PHP, you can look at these things. And I did find something here. So it was a reflected cross-site scripting, in this case only impacting potentially site admins. For remote code execution, you have these. I didn't find anything, so that's good news. For SQL injection, the same. And at this point, you might be asking, okay, this is a lot of strings to look for. In fact, this is actually quite a lot of work. So it meant that I had to do a find all and then go through all the code locations, check what is around it, check the flow up to that point, and so on. First, and server-side request forgery, you have this. And then I looked at another component of MISP. This is the ACL component. So what's interesting here, the ACL component contains a list of all the endpoints that MISP has, as well as the high-level, let's say, access restrictions for this endpoint. So for an attacker, this is quite an interesting file because you basically get a list of all the functions that MISP has. While going through this, I realized that you have a couple of functions like import, report from URL, send to LLM, and so on, which were accessible to all users. When I continued looking at those functions, I realized that also at the next step, there was no check making sure that you were supposed to have access. So what this allowed you to do is even if you were a read-only user, you could use these functions to add some data, which of course you are not supposed to do, to be able to do. But what was worse, it was also missing some other checks. So with a read-only user, I could inject data into another organization's events. It gets worse later on, I will show you, but at the end you also had injection of a XSS payload. So I found a cross-site scripting vulnerability in an event report, and I could use this vulnerability to inject this cross-site scripting exploit into someone else's events data. Now imagine that I would manage to do that on a threat intel provider's instance and they would publish it. It would be spread to a lot of different instances. Third strategy I used was looking at previously disclosed vulnerabilities in MISP. So there's a security advisory page, and I had a look at this is from last year actually. I saw there was a security fix for missing ACL on audit logs controller. So audit logs contain a set of logs indicating, for example, this event was changed, this was the old data, and this is the new data. So if you manage to get access to that, you can get access to the data that is on MISP as well. Looking at that fix, I realized that there was another function, another endpoint called full change, which when I saw this in the code, I didn't even know what it was. So I had to check the page and figure out where it was called to know what it does. So there is at some point, if the change in MISP is too large, it will actually only show you a part of it, but you can double click on the page and then it will fetch this whole content of the change. And this endpoint was not fixed when they fixed the previous vulnerability. So impact here is data leaked and potential lateral movement if you manage to get an API key or something like that through it. I also looked at external reports. So last year there was this top 10, or every year Portsweiger has a top 10 web hacking techniques call. To give you some context, again, we have this community sharing. So if you manage to compromise one of the instances, you can potentially compromise all of them. And I will just show you here how I crafted an exploit for this, because I personally didn't really know how far you can go with a cross-site scripting vulnerability. When you look it up, they say you can take over the whole browser and do basically everything the user can. But I had never seen that in practice, so I thought I played around with it a bit, and this is the exploit I came up with. So you see here that I am logged in with the organization admin for a specific user. CSP enforce is set on the instance, so this blocks you from doing certain things. But I have an attacker-controlled service waiting for a request, some payload in a MISP attribute. And when I go to the event report, okay, some flashy stuff is happening behind the screen, but basically what's happening is if you execute this as a site admin, it will first disable CSP enforce, which now allows you to execute some JavaScript and reach out to an external service, but it's only applied on the next reload. So I have some logic to reload the event report. And then when it sees a specific query parameter in the URL or in the request, it will execute the second stage of the payload, which is to create an authentication key for this logged in user and send it to my attacker server together with the domain of the instance. So I know who is compromised, and I have a site admin API key. There is a lot more potential with this kind of flow, but I'll leave it at that. Again, thinking back with if I manage to inject this kind of payload into a threat intel provider's instance or another big instance, that would have potentially spread to all these connected instances. Fourth approach was to review config options. So inside MISP, you have something called REST client. It allows you to test REST requests to MISP. But if you are a site admin, and in the past it used to be even looser access, let's say, but you were able as a site admin to basically set the base URL that this client would reach out to any specified URL. So, and you can do get and post requests, meaning that if you manage to get site admin, you could also do server-side request forgery to the entire internal network with get and post requests with any headers that you want. And then the fifth approach is simply just reviewing all the codes and commits and change logs. Yes, I am doing that. And this led to this discovery, which I also found extremely interesting and funny in a way, because so this functionality, when I started looking at it, it was completely broken. So you had to be pretty motivated to get it working. So I spent around one day, let's say, to figure out how to make it work. The intention here is that you can download event reports as a PDF. And I happened to see some blog posts around this time that a lot of these libraries have vulnerabilities, and quite bad vulnerabilities. So I was interested in checking this. So once I managed to get it working, I played around a bit, and I had a sort of exploit, but it took until I used Hack the Box Academy specific training to figure out how to completely abuse it, and it basically led to a HTML injection and server-side request forgery, which allowed me to include any or a bunch of local files in the PDF that's generated. So by setting a specific payload here, I would get a PDF that I can download, which contains local files from the server. The impact here was none in a way, because I found it before it was functional. So that's good news. For the fixed functionality, it would be what I mentioned. And still now, the recommendation is to only use this specific function on internal systems with very limited access. It's patched, but I don't know if it's fully patched. So going to consolidated findings, I have about 34 MISP, or there are about 34 MISP commits, security commits related to things that I reported. I think around 30 of those were from the last years. I didn't really go through the effort to rank them on severity, but I know at least 2 of them were critical. I also had a look at some other Circle tools, because Circle is really nice to work with. Every time you report something to them, they are responsive. They don't tell me, go away, please. Only sometimes, let's say. So again, on Cerebrate, I had already found some vulnerabilities. On vulnerability lookup, I recently found 7, and these have been fixed as well. Rules at 2, Flow Intel 1, and Lookilo 1. And yeah. Unfortunately, I didn't find anything on Lacus. If you remember my intro slide, you will realize why. Bad pool. Okay, going to recommendations for MISP users. First one is please make sure you update frequently. So I am also on my day job managing some big MISP communities, and I see that the ones that we interact with are not always updated as well as they should be. So most of these fixes should be from December 2024. So normally you already patched them. If not, then please reassess also your life choices. The second thing is limit site admin usage, and this is something I was also messing up. So this vulnerability that I showed, if the exploit that I did would only work with site admin, I also had this bad habit to use site admin for everything, because I don't want to constantly log in with different users. But so that's a bad idea. You also want to monitor site admin activity and hotkey creation. And ideally, and this is a bit tricky, but I really think it would be good to limit site admin specific pages, access to site admin specific pages to an allow listed IP range, just to avoid any abuse. Second thing, I see that if you can review your hotkey creations, you never know, somebody might have abused this vulnerability. If you use MISP modules, install them on a separate server or in a container. And if you can, always reach out to MISP project team with any bugs or potential improvements that you have. Don't be afraid to reach out. Some recommendations for the MISP project team. So there are some really good girls and boys in the driver's seat over there. If you are interested, join the club. They are nice. I'm also part of the community. I think I'm also not too bad. Continuing fostering community engagement. I think Circle is doing a great job, and the MISP project team is doing a great job with this kind of events, with the way they interact with people, to make it nice to be part of the contributing team. And also to look into optimizing automated testing. So I think there's some effort that can be done here as well. Some personal reflections for myself. So at some point I was wondering to myself, am I wasting my time here? Especially when I was having a look at Cerebrate. This was at the beginning. I hadn't ever found a cross-site scripting vulnerability, and I was like, yeah, this would be so cool if I found it. But Cerebrate is pretty well done. So they are using, let's say, reusable code for all the different views, and it looks like the separate elements are really, really well done. So I actually went through, I think, every single view that was there, and I couldn't spot anything. But I come from a testing background as well. And for me personally, not finding an issue is also an outcome, and in some ways even a better outcome than finding issues. So again, since in this case, I had a pretty structured approach, I went through every single file. So I had a checkbox saying, okay, I did this. This increased my confidence in the project as well. And this is what I want for MISP too, that because I'm running big instances, I really want to be confident that it works, it continues to work, and it's secure. So what makes you happy? It's all in your head. It can be, in my case, it is contributing to a final good product. Increasing confidence in the product is also a win in my book. And I like working on interesting technology, which this definitely is. Maybe some final words. LLM usage. The first time I started with it, it was going completely insane, especially with MISP. So it made me go down rabbit holes, and at some point I decided it's not really worth it to take this approach. It's better just to do a manual code review. However, it got better, and in the recent times I actually found some things. Second thing, even reviewing commits can be helpful and fun. Sometimes it only takes 5 or 10 minutes to spot something off and to report it, and then Andres says, oh no, more. So what's next for me? I will continue doing similar work. I didn't have a look at the sync yet, so that's high on my to-do list. And I also want to work on documentation and automated testing. I don't want to go way too much over time. So I would just like to point out that I wrote a longer blog post about the approach that I took, the motivation and so on. It's been published today. So if you're interested, please go to jeroenpinoy.website and you have all the details there.
Thanks a lot, Jeroen.